When we have a lens, we change the medium through which light passes. As we saw with Snell's law, this means we get refraction, or bending of light. In this class, we use the thin lens approximation, meaning the material the lens is made of, which is typically glass, is so thin that we don't need to worry too much about what's going inside the glass itself. One type of lens that we look at is a converging lens. This type of lens is thinner at its edges and thicker in the middle. What it does is focus incoming light rays toward its focal length to try to actually create a real image. So let's look at a ray diagram to understand this. Again, we'll define three principal rays that you'll use for these diagrams. The first one comes in parallel and will be focused through the focal length of the converging lens on the other side. So I come in parallel and I go through that focal length. The central ray will go straight through the middle of that lens and be bent unperturbed. So it'll go straight through without changing direction, and we can discuss that, at office hours. The focal ray will go through the near side focal length and emerge parallel. So as you can see, in this case, by having these light rays come in, we're actually converging the light to one point. So because these light rays actually converge, we created a real image. Now think about all the different positions you can have. You could be inside the focal length, at the focal length, or beyond it. In all cases, these different DOs with the same Fs will result in different DIs that are inverted, upside down, left, right, who knows. You should be able to work through all of these to figure out all of the scenarios that you'll need to know.